Hello! Today's challenge involves finding missing numbers. We start with 2 pancakes, each with a number on the front and on the back. If we toss the pancakes and work out the total of the numbers we can see on the top each time, we would eventually end up with the consecutive answers 9, 10, 11 and 12, which simply means they are numbers which follow on from each other. The first part of the challenge is to work out what numbers are written on the back or reverse of each pancake. Let's have a look at some we made earlier. The best way to solve this question is to use an ordered approach to make sure we find all the possible answers in the most efficient way. So we could start with what we already know. We know that we need to make the totals 9, 10, 11 and 12. We also know the number on the top of each pancake. We can therefore calculate our first total by adding the numbers we know like this. 4 add 5 equals 9. Next, we need to calculate all the possible numbers to make the remaining totals. So let's consider each pancake in turn. What possible numbers then could be on the back of this right-hand pancake? Let's consider all the remaining totals we need to find. 10, 11 and 12. In this case, 4 add what would give us each of these totals? By calculating the missing numbers, we can find out that 4 add 6 equals 10, 4 add 7 equals 11, and 4 add 8 equals 12, which means the number on the back of this pancake is 6, 7 or 8. In exactly the same way, we can calculate the possible numbers on the back of the left-hand pancake. We still need to find the totals 10, 11 and 12, but this time we need to work out what number add 5 would give us each of the totals. So by calculating these missing numbers, we find out that 5 add 5 equals 10, 6 add 5 equals 11, and 7 add 5 equals 12, which means that the number on the back of this pancake is 5, 6 or 7. But how can we narrow it down? To do this, we need to consider the possible totals when we add the numbers on the reverse of both of the pancakes together. So, which combinations of these numbers total 9, 10, 11 or 12? Well, we can calculate that 5 add 6 equals 11, 5 add 7 equals 12, and 6 add 6 also equals 12. But this demonstrates that the 7 on the left and the 8 on the right cannot be used in any combination to make any of the totals needed. In this way, we have identified that the 5 and the 6 and the 6 and the 7 are all possibilities for the numbers on the backs of the 2 pancakes. All that is left for us to do then is to identify which of the possibilities work as a set of numbers to make the 4 consecutive totals needed. So, returning to the beginning, we know that 4 add 5 equals 9. We also calculated that 4 add 6 equals 10. And by using what we have found out to make the next calculation correct, then the number on the back of the left-hand pancake must be 6, so that 6 add 5 equals 11, which just leaves us to confirm our possibilities with the final combination of numbers. We see that 6 add 6 does indeed equal 12. So what about the 5 and the 7? Can we replace them in our calculations to make another set of numbers which work? Yes, we can. 4 add 5 still equals 9. 4 add 7, however, equals 11, and 5 add 5 equals 10, and 5 add 7 equals 12. With these calculations, we have answered the first part of the challenge and found out that there are two possible answers. The numbers on the reverse of the pancakes are either 6 and 6 or 5 and 7.